So this is the first part of the video for the second exam. So this is the start of the review that's on page 180. So I will split it up in the pages. So we're starting on 180. So the first part here basically says determine which of these are actually solutions to the line. So what you do is just plug in your x and y points. So we know this is x, this is x, this is y. So you'll have 3 times 3 minus 2 times 1 equals 7. 9 minus 2 equals 7. 7 equals 7. So A was a point on the line. Now you'll just continue and do that through all of these. And the only one I'm going to do next is this one because I think you get the picture here. So we would have 3 times a third minus 2 times 3, times negative 3 equals 7. So that's 1. Remember, 3 times a third is the same thing as 3 divided by 3. So then we have 1 plus 6 equals 7. 7 equals 7. So also D worked. So then you just check the other two by plugging them in. So it says graph by plotting points. So remember, we want to graph lines in y equals mx plus b. Number 5 already is. Then because it says by plotting points, you'll just make an xy chart, plug in -2, -1, 0, 1, and 2. So then you'll calculate, we get 0, we get 1, we get 2, plug in 1, you get 3, plug in 2, you get 4, and then you'll plot the points. So it makes sense, right? -2, 0, -1 up 1, over 0 up 2, and then over 1 up 3, and I think we get the picture here. So then you would graph your line. Okay. Same thing here, it says graph by plotting points. So I would make an XY chart here. And then -2, -1, 0, 1, 2 is usually where I start. And then if I need more points, I can. So with this one, we're going to have 2 times -2 squared minus 3. So careful to make sure to do that. That's 4 times 2 is 8. 8 minus 3 is 5. Then we have 2 times -1 squared minus 3. So you calculate that, that's 1. 1 times 2 is 2, minus 3 is -1. Plugging in 0, we get -3. Plugging in 1, we also get -1. Plugging in 2, we get 5. Okay, so we have our parabola, notice degree 2. But your points will all show you exactly what to do. So -2 up 5, over -1 up down 1. Is it down 1? Yeah. Over 0, down 3 units, over 1, up, down 1, over 2, up 5. And there is your quadratic. So pretty easy stuff. Okay, so let's graph these. So everybody graphing absolute value. Once again, we're graphing by plotting points, -2, -1, 0, 1, 2. So if we plug in, we would -2, we'd have negative absolute value of -2 minus 2. So then this becomes positive 2. So then there's a minus sign in front of that. So it's -2 minus 2, which is -4. Plugging in -1, we have -1 minus 2. So this becomes positive 1. So then the negative in front would be -1 minus 2 is -3. Plugging in 0, we'd get -2. Plugging in 1, we'd get -1. Plugging in 2, we'd get 0. And we'd probably want more points than this. So, but let's see, maybe we'll be able to see what's going on. So if you don't know this, absolute values are V graphs. So you definitely want to graph as many as possible to get some more answers here. So if we plug in 3, we get -5. Right. Okay, let's do this. So we're at -2. Down 4, hard to see on this graph, over -1, down 3, over 0, down 2. Uh-oh. I graphed that on the same one, that was right there. Okay, awesome, that's better. Then over 1, down -1. If we plug in 1, we shouldn't get -1, we should get -3. That's where my problem is. So then we're going over 1, down 3. And then if I plug in 3, I should have -5. No. Over 3, down 5. So it is looking like this V graph, which is good. Okay, awesome. Okay, just be careful with that. make an XY chart, -2, -1, 0, 1, 2. Plugging in -2 cubed is -8, -8 plus 2 is -6, -1 cubed is -1, -1 plus 2 is 1, 0 cubed plus 2 is 2, 1 cubed is 1, so 3. Plug in 2, you get 8, 9, 10. So we have -2 down 6, -1 up 1, over 0 up 2, over 1 up 3, over 2 up 10, which is up here somewhere. So there's our x cubed graph. So graphing by plotting points shouldn't be too bad. All right, so looking at this one, it says graph. Now, once again, by plotting points, I would definitely always get it into y equals mx plus b form. So that's just me though. Subtract 1, x minus 1 equals y squared. Square root, so when solving and taking a square root, I need a plus or minus. Y is equal to plus and minus the square root of x minus 1. Make an XY chart here. Let's try -2, -1, 0, 1, 2. We'll start there. If we need to do more, we can. So that would be plus or minus the square root of -3, which we wouldn't want to do that point because the square root of a negative is I. So we'd have plus or minus the square root of -2. Still wouldn't do that point. Plugging in 0. Plus and minus square root of -1, still I. Plugging in 1, that'd be plus and minus root 0, which is 0. Plugging in 2, that'd be plus and minus square root of 1, which is plus and minus 1. Okay, that's some good points. Let's try 3. If I plug in 3, I'll have plus and minus the square root of 2. I don't want to do decimals, moving on. Plugging in 4, plus and minus root 3, decimal, I'm going to keep going. I want at least one more whole number point. So plugging in 5, that'd be plus and minus the square root of 4, which is plus and minus 2. So we have the point over 1 up 0, because plus and minus 0 is the same thing, so I am going to use this point. Then I'm going to use over 2 up 1, over 2 down 1, and I'm going to use over 5 up 2, over 5 down 2. And now I have my sideways parabola, which makes sense, guys. Remember our equation here, since it has plus and minus the square root, this is our sideways parabola. So this is not considered a function. So let's go back. Let's say on the test they said, graph by plotting points, is this a function? Yes, a line is a function. It passes the vertical line test. Yes, this is a function. It passes the vertical line test. Yes, this is a function because it passes the vertical line test. This is also a function. It passes the vertical line test. Now this, however, is not a function. It does not pass the vertical line test, but we can still graph it. This is find the intercepts, so we can just eyeball it. So you would write specifically x-intercepts. That's where it crosses the x-axis. We write these as xy points. That would be -3 up 0. Y-intercepts are when x equals 0, but we can just look over 0 up 3, over 0 down 1, and then same thing here. So you'd say x-intercepts are where it crosses the x-axis, so it looks like that's -3 up 0, then 0, 0, then over 2 up 0. Our y-intercept is 0, 0. Notice our x and y-intercept are the same. That's okay. That will happen. Okay, let's read 17. A cell phone company offers a plan for $40 per month for 3,000 minutes with additional minutes costing 5 cents per minute. Use the graph to the right to answer the questions. So they modeled this out for us. So notice right here, no matter what, at 0, you are paying $40. Now, that makes sense, right? Even 0 minutes, no matter what, you have to pay $40 per month. And then it says for the first, hold on, the announcements are annoying. Now notice it also says that for the first 3,000 minutes, that's $40. So notice the line stays consistent. You're only paying $40. Now this must down here be in minutes and thousands. So then it looks like 3, 6, 9, notice, so 3, 6, 9, 12, 13, 14, 15, 18, you get the picture. These are thousands minutes. So notice at 3,000, we're still at only $40. We're up at $40, and this is the cost per month. And then after that, it just starts to rise really quickly here. If you're talking more than 3,000 minutes, they're then charging you 5 cents per minute, which is a lot. So in part A, it says, if you talk for 2,250 minutes in a month, how much is your monthly bill? Well, that's under right here. That's 2,250. They're only going to be paying $40, correct? Because that's still under 3,000 minutes. Part B, use the graph to estimate your monthly bill if you talk for 12,000 minutes. Let's go to 12,000. We're estimating, so I'm going to go about right there-ish. We're estimating, so we don't have to be perfect. So to me, it looks like we're going in 250s, right? So let's see, 250. Yep, so this would be about 7, so right here is 250, 500, add 250 again, that would be about $750. Yikes, that's a lot of money. Okay, good. Okay, number 19, it says write as ordered pairs, state the domain and range. Really easy. So we're gonna go, I'm just gonna abbreviate sent 2500. Then we have nickel, comma, 5.000. Then we have quarter, comma, 5.670. Then we have half dollar, comma, 11.340. Then we have dollar, comma, 8.100. So then it says, what's the domain? Well, this is the domain. XLIs are the domain. So instead of listing it out, I'm just going to verbally state it. Our domain is cent, nickel, dime, quarter, half, dollar, and dollar. And our range is our Y values, always. So our range is our output, which is the weight. 2.5, 5.0, 5.6, 7, 11.34, and 8.1. Write each relation as a map. So the last one was a map to ordered pair. Now we're going ordered pair to map. So you'll just draw your little thing here. So X values were 2, negative 4, 3, 6, negative 2. Your Y values were 7, 8, 5, negative 1, negative 9. And then we'll just point arrows. 2 was to 7, negative 4 was to 8. 3 was to 5. Now, really, it would probably be best to reorder this in order from least to greatest, but I'm not going to be actually picky. And then same thing here, reorder this from least to greatest, and then point the arrows accordingly. But I'm not going to be picky about it, so this would be good enough. It just understands that you know X values are domain, Y values are range. Input, output. Okay, this is identify the domain and range. You should be able to identify this pretty easily. Now, domain is X values. So if you look at this function right here, it's growing left and right forever. It's growing that way forever, not down. I'm not talking down. Down is range. Domain is left and right. This is growing to the left forever and to the right forever. So our domain is negative infinity to infinity. Now, our range is our Y values. Where is it growing from down to up? It's growing to negative infinity and positive infinity. So that one's domain and range is the same. Now, if you look at this one, our domain is X values. So it shows us we're going from negative 6 to 4. The furthest left we are for our domain is negative 6, including negative 6, because that was a point on the graph, comma, and the furthest right we're going is positive 4, including 4. And our range would be the lowest value down. Now, remember, this is Y values, so you got to do the Y values. Our lowest value down is at negative 4. And our highest value up was at 8, because remember, range is Y values. So notice for domain, I did our X values from left to right, and for range, I'm doing my Y values from down to up. And it includes those values. Negative 4 is included. That is a point on the graph, so we would make sure to put brackets. Sorry. So domain here, our domain is X values. Notice X always equals 2, no matter what. Then our range is from negative infinity to infinity. And notice this isn't considered a function because it doesn't pass the vertical line test. It is a vertical line. So each X has multiple Y values. So this wouldn't be considered a function, but our domain is X equals 2. Our range is negative infinity to infinity. All right, here we go. So looking at this one, what's the domain? Domain is left and right. So make sure you go, oh, what's the furthest left I am? Oh, that's at negative 1. So our domain is from bracket negative 1 to infinity, and our range is starting down here at negative 2. Make sure you're looking up and down for range. It's at negative 2 to going up to infinity. Domain and range, not bad. We've been doing this for years, so we didn't really practice it too much, but it's because hopefully you were good with domain and range. Okay, it says, is the relation a function? So remember, each X can only have one Y. So does negative 1 have more than one Y value? Yikes. Negative 1 has a negative 2 and negative 1 has a 3. So So this is not considered a function. Each x can only have one y value. So right here, camel only goes to 50, macaw only goes to 50, deer goes to 14, fox goes to 22, tiger goes to 45, croc goes to 35. So each x only points to one y. Now notice, yes, some of the x's point to the same y, but they're different x values, or input values. Input can only point to one output. So this one is a yes. It is a function. Now what would change that is if camel had another arrow going to like 35, because camel had then 50 and 35 as output. So hopefully you understand the difference. Determine if y is a function of x. So remember, I always get y equals as my function, and then I just look. So subtract 3x, negative 5y equals negative 3x plus 18, divide by negative 5. So y is equal to 3/5 x minus 18/5. And lines are functions. They pass the vertical line test. Now recall, the only time we would be saying no is if we had a plus or minus. So if you look right here, you'd say, I need to get y by itself, so I'm going to subtract x squared. So then I have y squared equals 81 minus x squared. Then I square root it. Oh, when solving and taking a square root, I need to put a plus or minus. So y is equal to plus and minus the square root of 81 minus x squared. Now everybody, don't be tempted to just square root that and square root that, because you can't square root across subtraction signs. So this is as simplified as it gets. Now the problem is the plus or minus, right? That's the problem. So because if I plug something in, we're going to get out a positive and a negative answer. So when we plug something in, we got two answers out. So this one is not considered a function. No, this one is a yes. Okay. Plus or minus means no. So looking here, is y a function of x? No, plus and minus, right here. Does this pass the vertical line test? No. So that would not be a function. Right here, y equals x squared minus 14. We're not having to solve for y. Y is already solved for. We are not going to take a square root here because y is already by itself. Here we had to get y alone, so we had to take a square root. But once again, we already have y equals x squared minus 14. Quadratics are indeed functions, so this one is a yes. And then lines pass the vertical line test, so this would indeed be a yes as well. Okay, is this a function, is y a function of x? The answer is yes, it passes the vertical line test. If you draw vertical lines, it only ever touches once. Does this weird ski-wampa circle pass the vertical line test? No, it hits your pencil twice in one x spot. All right, 49 says, find f of negative 2. So what we're going to do is just plug in negative 2 using parentheses, negative 2 squared plus 2 times negative 2 minus 5. Now be careful, if you type this into your calculator, you have to use parentheses. So I would just think about it. What's negative 2 times negative 2? 4. So 4 minus 4 minus 5. 4 minus 4 is 0, so negative 5 would be our answer. If it said plug in 3, at the 3 we plug in 3. Okay, let's keep going. So this says find f of 5. So we know it means plug in 5. So we would have negative 2 times 5 plus 7. Negative 10 plus 7 is negative 3. Hey, look, find f of negative x. That means take your x, your negative x, and plug it in wherever there's an x. So that'd be negative 2, and instead of an x, I'm doing plugging in negative x. Plus 7, then simplify it. And negative times a negative is a positive. Positive 2x plus 7. That would be your answer. If I said to you, find g of x, then g of x is 2x plus 1, find g of x plus h. Remember, you just take that and replace your x with x plus h. So you have 2 parentheses x plus h. Anytime we make a substitution, it's smart to put parentheses plus 1. Then to simplify it, I'll distribute my 2. 2x plus 2h plus 1. Awesome. Okay. So given p of x is equal to this equation, they kind of go into a little bit more detail in the book, so just read it. But basically, they're giving us this equation, and they're telling us it represents the population T years after 1990. In part A, it says, identify the dependent and independent variables. Now remember, dependent is our output, independent is input, because you can input anything. So what is our T's? T's are input, right? That's what we plug in is for T. What did T stand for? Years. So our independent is T, which equals time. And our dependent, the year depends on the time, right? It says represents population, my bad. So we plug something in, certain year we plug in and we get out a population. So a dependent variable is the population based on the time. So dependent would be our P of t, or your y values, which is population. Input, we input time, we get out population. Input, output. Input is independent. We can plug in anything we want. Our output depends on what we plug in. Evaluate P of 110 and explain what it means. So that means it's year. If we plug in 110, then we would just literally plug it in and use our calculator. So that'd be 0.144 times 100 squared minus 6.613 times it's 110. Sorry, 110. Plugging in 110. And then plus 104.448. So we would get some number. I'm not going to take the time to calculate it because I have confidence you could type it into your calculator exactly as you see it. And if you couldn't type it in exactly as you see it, you'd make sure to go in order as such. You would go 110 times 110, then times it to that, and then after that you would just add it up to the rest of this. So it says, what does it mean? Well, remember 110, for a minute I was almost like, whoa, 110 years, but remember it says represents a population after 1990. So how many years is 110 after 1990? Well, to get to 100, we're going 10, and then to get to a 110, we're going 10 more, that's 20. So you'd say 20 years after 1990, this was our population. So if you got a negative answer, you would know something went wrong. It makes no sense to have a negative population. Now it says evaluate P of negative 70 and explain what it means. So once again, you would just plug in negative 70. So you would do 0.144 times negative 70 squared minus 6.613 times negative 70, and then plus 104.448. That doesn't mean we're going negative in time, but we are going back in time in a sense, because in 1990, if we're going negative 70, take off 70 years, and that would be 1920, correct? So we're going back, basically back in time. Yeah. So then you would say in 1920, the population was that. So hopefully that makes sense to you. All right, that's the first half of the exam. We'll now do in a different video the second half.